Hi grade 10, it's Miss OG here. We're going to start day 1 of exponential functions. So to begin with, what you need to be aware of is what an exponent is. And all it is the power. Okay. Exponent is just another name for power, index, they're all the same thing. So when you have an exponent, it's made up of two parts. You have the base, which is just the bottom number, or the bottom could be a number or a letter. Okay, so that's what we call the base of the exponent. And then we have the actual power, which is what we call the exponent. Okay, to start with, the first day we're just going to look at rules that you should have already seen somewhere along the way and just revise those rules. So let's get stuck into it. So you should also remember that when we have powers or exponents, that power just tells us how many times we multiply by itself. So x squared means that we multiply by itself 2 times. X cubed, so then we could write that as x times x like we have there. And then x cubed is x times x times x 3 times. And then, of course, we can just rewrite that exponent in a shorter way, because now we have 5 x's multiplied together. So we just write that as x to the power of 5. And we're done. If we use a similar method then, x to the power of 4 times x. Now remember, if there's no power written there, it's to the power of 1. So we'd have x times by itself 4 times, first of all, and then times by the other x. So again, we now have 1, 2, 3, 4, 5. So a quicker way to write that is just x to the power of 5. Similarly, if we do it here, x squared, as we know, means times by itself twice, and then multiplied by another x squared, so x times x again. Then to write that in a shorter way, we've got 4 x's multiplied by itself, so we write that as x to the power of 4. Okay, now we want to quickly decide, well, obviously we don't want to have to write this every single time all the big long way. That's a little bit time consuming. So if we look for the pattern, our answer had a power of 5, and there we have 2 and 3. Our question had a 4 and a 1 in the power, and the answer had 5. The question had 2 and 2, and the answer had 4. So hopefully you can already see by now that what you should notice is that when you multiply the exponents, then a quick way to get the answer is just to add the powers. So in general, if we have x to the power of m times x to the power of n, we can just add those powers. No matter what m and n are, they can be any numbers we like. And that's the quick way. Okay, that you should have seen at some stage during your mathematical career. Okay, let's look at the second one, division. So here we have x to the power of 4 divided by x to the power of 2. So again, if we use the same process, write out it's to the power of 4, so we have 4 x's multiplied by itself, and then we have 2 x's multiplied by itself there. What we can do then is we can actually cancel, because x divided by x we know is 1. X divided by x is 1. So what we have left here is just x times x, which of course is x squared. If we do a similar thing here, so we'll have x times x times x, that's 3, times another one, and one more for 5. And that's all going to be over x squared, which we can write, of course, as x times x. So if I do some cancelling, x over x is 1, x over x is 1. What do I have left? X times x times x on the top. So I've got x cubed. Finally, one more. X times x times x, that's the x cubed, all over, because remember, of course, we can change a division to a fraction. That's what that fraction line means, is to divide. X times x on the bottom, and then if we quickly do some cancelling, we have x over x is 1, x over x is 1. So we're just left with x. Of course, that's to the power of 1, but we don't need to write that. Again, quickly looking for that pattern then. Hopefully you've already noticed we have a 4 and a 2 in our question, and in our answer we had a power of 2. We had a 5 and a 2 in our question, and the answer was a power of 3. A 3 and a 2 in the question, and then in the answer a power of 1. So hopefully what you've noticed is this time, when we're dividing exponents, the quick way to do it, of course, is we just subtract them. Okay, we divide two exponents. Now what's really important here is this rule only works when the bases are the same. So they're both x, or they're both the number 2, or whatever it might be. This only works in that case. And then if they are the same, you can literally just subtract those two numbers, whatever they might be. Good, that's the second one. Again, you should have seen that at some point. The next one, I always call it the power to a power rule, because you have a power inside the bracket and a power outside. So we know squared means multiplied by itself, so we'll have x cubed squared, so we have x times x. Then, if we just use our rule from the first rule from above, we know that we can just add the powers. 3 plus 3 is 6, so we get x to the power of 6. So here, x to the 4 cubed, so that means x to the 4 times x to the 4 times another x to the 4. And again, using our addition rule, 4 plus 4 is 8, plus 4 is 12. So we get x to the power of 12. And lastly, x to the power of 6 to the power of 4, so we need that multiplied by itself 4 times. One more. Again, using the addition rule, 6 plus 6 is 12, plus another 6 is 18, plus another 6 is 24. So we have x to the power of 24. Again, hopefully you've quickly seen what the rule is, so we don't have to do this every time. We get a power of 6 in the answer, and when we had 3 and 2, one inside, one outside. A 4 and a 3 in our question, and we get 12 in our answer. A 6 and a 4 in the question, we get 24. So hopefully you can see then very easily that the connection there is when you have a power inside and a power outside the bracket, all you have to do is multiply the two powers. So we can say that's the same as mn, or m times n. Okay, good. So they are the three exponential rules that you should have seen before. And then of course here you've got a summary of that. We've just shown you how you can generalize the first three. The second two just say that you can distribute that power. If you have two things multiplied inside the bracket, you can just take that power of them individually. So x to the power of m times y to the power of m. They are the same thing. And then similarly, if we have two things divided in the bracket, you can raise that power to each of them individually, which sometimes is easier to do, you'll see when we do some of the examples. All right, good. Let's see then, putting this all into practice with some examples here. So we'll start off super easy. X to the power of 6 times x to the power of 8. It's a multiplication. Our bases are the same, so all we have to do is add the powers. 6 plus 8 is 14. Simple. This one, don't forget, this is the same as 3 times y to the 4 times 6 times y to the 5. So the numerical parts with multiplication, doesn't matter which order you do it in. So we can just multiply the numbers first. 3 times 6 is 18. And then we use our rule for the exponent part. Y to the power of 4 times y to the power of 5. It's being multiplied, so we add the exponents, so we get y to the power of 9. Now, be very careful here. When the bases are numbers, the rules work exactly the same. However, you do not change the base. Just like here, when there were y's, we didn't change the y's in any way. So the base always remains the same, 3. They are being multiplied. Our exponents are 4 and 2. So we do 3 to the power of 6. Okay, that's it. Of course, you can then use your calculator to actually work out the answer to that. Here, doing the division, m to the power of 9 divided by m to the power of 7. We're dividing, that means we use the second rule where we subtract the powers. So that becomes m squared. Now remember, division can be written as a fraction and you treat it the same way. So here, just like you would with a fraction, if you have 24 over 16, we need to find the biggest number that goes into 24 and 16. I think 8 might be the biggest, so 8 goes into 24 3 times, 8 goes into 16 2 times, and then here, if you imagine, we'd have n times n times n times n times n 5 times on the top, and we'd have it 3 times in the bottom. So we can cancel out n cubed, and we'd be left with 2 of them on the top. So if we look what's left, we've got a 3, we've got an n, and you could just use your division rule as well. 5 minus 3 is 2. So 3n squared, and don't forget you have that 2 on the denominator. Here, same thing as above, 5 to the power of 6 divided by 5 to the power of 4. The bases don't change, so do not write that as 25. The base stays the same. You're dividing, so you subtract the powers, so that becomes 5 squared. Of course, that's an easy one to do in our head. That's just 25. Okay, last 3. Here, power inside, power outside. So we just multiply the powers. Simple. 4 times 5 is 20. That's all you have to do. Now, be careful here. You've got 2 times b to the 6. Now remember, there was the rule when you have things multiplied in the bracket, you have to raise each of them to that power. So if I write this out the long way, it's the same as saying 2 cubed times b to the power of 6 cubed. So don't forget, the common mistake is to forget the 2. 2 cubed is 8. And then here we have power inside, power outside. We multiply them, so 6 times 3 is 18. Okay, good. Then here, same thing, even if there are numbers there, base stays the same. Base never changes. And then we have power inside, power outside, 2 to the power of 16. That's quite a big number, so we can just leave that in exact form. Oh, that's all right, I had one more. Now, sometimes you have multiple rules that you have to use in one question. So just don't try and do it all at once. Simplify numerator, denominator separately, and then worry about doing something with the division. So if we look at the numerator here, we can do 2 times 6 is 12. X to the 5 times x cubed is we add the powers, so it's x to the 8 all over. Now don't forget here, you've got to square everything. So you have to square the 3, which is 9. And then you have x squared to the power of 2. Power inside, power outside, so we multiply them. Here we need another line of working because we need to do some cancelling here. Find the biggest number that goes into 12 and 9. I think 3 will do it. So 3 goes into 12. Oops, sorry, I made a little mistake there. 3 goes into 12 4 times. Let's get that pen back. And 3 goes into 9 3 times. Here we can then just either think of it as cancelling or use, because when it's a fraction it's the same as dividing. So we can subtract the powers. We have the bigger power on top, so that would stay in the numerator. 8 minus 4 is 4, and we still have that 3 in the denominator. Okay, so just be careful with these ones. They're not normally much harder than all the other ones. You just need to take your time. Okay, guys, hopefully that's enough of a refresher to have a little practice on your own. Bye.